The universe is everything. Everything we see, hear, feel, and the countless things that we don't. They all come together to make up what we know as the universe. However, it was not always like this. The universe was once empty and dark. There was nothing, but a pinprick of light was still there among all this nothingness. And one day, this incredibly dense thing exploded. This was known as the Big Bang.
Yes! Oh my God!
Now in this universe we had waves. Tons of electromagnetic waves, as far as the eye could and couldn't see. We measured these waves using the electromagnetic spectrum, which shows all the different types of waves, from the long, low-frequency radio waves, which you find in everyday things such as the radio, to high-frequency gamma rays, which can be found in things such as nuclear bombs.
Tactical nuke incoming!
By the way, the wavelength is how long the waves are, and the frequency is how frequently they happen. Alright, so now moving on to space stuff. In space, you'll find a bunch of these galaxies, right? And there's like 1,000,000 billion of them. But then inside of the galaxy, there's like 1,000,000 billion of these burning balls of hydrogen and like helium and other elements called stars. And one of these stars is the sun. And it's like the only star inside of our solar system, and it's pretty important because it gives our Earth like light and stuff, and it also provides us with references to compare to other stars, which is pretty much how we like define our universe. Wait, that makes no sense. Okay, anyways, there's this thing called a spectroscope, and it lets us see everything in a spectrum so we can view its unique barcode, because just like the world is like a giant HEB and everything has a barcode. And there's also this thing called an HR diagram, or a Hertz-Russell diagram, which is this dude who created like a hot or not for stars, where he put them on a chart based on their hotness and their brightness. Okay, next we have redshift. Now, this is kind of complicated, so hold on to your seats, ladies and gentlemen. So the redshift is based on this theory that when something is coming towards you, the waves coming from it compress. And when something's going away from you, the waves coming from it like uncompress, and they're further away from each other. And so when something is moving away from us, the light waves are like uncompressed, so it looks red to us, because red has like a longer wavelength than blue. And so if it's the other way around and something's coming towards us, it's called a blue shift. This color thing is how we know whether stuff in the universe is moving further away from us or towards us. And so far we've seen that most of this stuff is moving away from us because it doesn't like us. Okay, so more space stuff. When we see all these stars, we see them at different brightnesses because they're a different lengths away from us. But this is only the apparent magnitude, because things aren't always what they seem. And so then later we figured out how to find out the absolute magnitude, which is how bright they actually are. Just look at all those stars. But wait, look closer. You might also see some nebulas out there, which are clouds of dust and gas. Also, more space stuff. There's this thing called a light year, which is actually not a measurement of time. It's a distance, and it's how far light travels in a year. So, as you can imagine, that's pretty far, because light is pretty fast. And so, yeah, lastly, we have this thing called a theory. A theory is like an idea that someone has about stuff, but they can't prove it. And so a lot of people have theories. There's like the Big Bang theory, because we don't really have a way to prove it. So speaking of theories, here we have Stephen Hawking to talk, and I'm going to talk to him about his theory. So, you say that there are an infinite amount of universes. Does that mean there's a universe where I'm smarter than you? Yes, and also a universe where your videos don't suck.